Oh, whoop, that's not what I meant to do. All right, so here is the question. Well, I guess almost all of you, but one got it. Okay, so basically it said N1 is the size of the tagged sample. And what did it say? N2, the size of the recaptured, right? Yeah, recaptured sample. And K, what did it say? Denotes number tag in the second sample. Yeah, so remember the formula we had, tag over total equals tag over total. That was the formula for solving those. Tag over total equals tag over total. And this was from the first catch, and this is the recapture, the second catch. So we're saying N1 is the size, and they said N1 is 64, N2 is 25, K is 8. So they said, okay, so size of the tagged sample, that'd be 64 tag, over size of the recaptured. Wait a minute, I'm confused. Yeah, that's right. Size of the recaptured sample, that goes down here, right? And the recaptured total. 8 is the number tagged in the second. Goes there? That what you guys all got? And then this is the capital N or X or whatever you want to call it, cross multiply. 64 times 25 is 8 times N. What's 64 times 5? 1600. Thank you. 8 times N divided by 8, and that's 200. And there it is. That's the answer, which almost all of you got. Very good. Good? Questions on that?
The homework was showing a little bit different.
A little different?
It's the same answer.
What would the homework show?
They wanted you to do N1 times N2 divided by K.
Yeah, so that's what I ended up doing. They're just kind of jumping. That's what, at this stage, see, this is N1. This is N2. And then what I divided by was K. So that ends up becoming that. They're just kind of jumping to that point and skipping the fraction step. They're kind of jumping right to there. Yeah, it ends up being that. Let's try. All right, let's get to the new stuff. So there we are. Weren't you guys finished chapter 13 homework okay? So we're doing the second part of stats now. Our exam right before Thanksgiving. So that would be 2 weeks from today. Today's the 7th, yeah. 2 weeks from today, we'll take our 4th exam. Remember, we have 5 exams total. The 5th one is not comprehensive. In other words, you can just forget about all that other stuff you've learned. It won't come back again. This is the only class. I joke, but it is kind of funny. This is the only class I teach where the final is not comprehensive. So it'll never come back again. So it's just the new stuff. So the exam we take 2 weeks from today, before Thanksgiving week, on Tuesday, is our 4th one. It's just all the stat stuff, chapters 13 and the 14 we're about to do. And then the last exam is on the finals day, but it's just that last 2 chapters. That's all it is.
You drop one exam, correct?
I do not. Yeah, that is not in the syllabus. Don't let that confuse you. I had a young lady one semester that she thought for sure I did that, and she just tanked hard, and she did not pass the class. Make no mistake. I dropped no exams. Because I do in my comprehensive classes. Maybe if you heard every other class I teach, the final's comprehensive. So I feel safe saying, hey, I'll let the final replace one of your exams. Because they still got to know everything to do well in the final. But in here, they're all separate. So it wouldn't be right, in my opinion, to drop an exam. Because that means you could just not learn that stuff at all.
So we're taking the final.
Yeah, the final's required. It is the last. And the final's actually the easiest test. That boosts people's grade. You'll want to take the final. That's the best scores are on that last exam. It's the easiest material. That last exam is the easiest of the 5 exams. Yeah. So anyway, yeah, so I don't drop an exam. Make sure you, don't make that mistake. They're all different. They all need to be in there. All right, so we're doing the second half of stats. Chapter 13 that we just finished was how you gather statistical information wisely. Chapter 14 now, is what do you do with it once you got it? Okay, I got all these numbers. What am I going to do with it? Think with me for a second, guys. What if you guys wanted to know how you did on the last exam? I could read them for you. Well, I don't know if you want me to. Let's just pretend these. Well, yeah, I know I don't want to mess around. Yeah, let's look here. What if this was your exam scores in the last exam? Let's just pretend. And you guys asked me. I never have heard you ask me. I was always interested, like how the class do as a whole. I kind of like to know, like where am I at? Am I hitting the middle? above, below, how's everybody doing? Where am I hitting for everybody else? What if I say, okay, you guys want to know how you did as a whole? I'll let you know how you did as a whole in the test. Ready? 100, 90, 80, 60, 60, 80, 70, 70, 60, 100, 190, 10, 20, 50, 50, 50, 70, 70, 70, 90, 90, 70, 90. That's how you did as a whole. Now, that's a terrible way to communicate, isn't it? I mean, I technically read all the scores and let you know every score, and so in a sense, you know how you did as a whole, but not really. Our brains don't work that way. Just reading a list of numbers does nothing for us. So, that's what this chapter is all about. What's a better way to describe a bunch of numbers, a whole, like, whatever that is, 20 numbers or whatever, so that we can kind of do something with it that makes sense to us? That's what this chapter is all about. How can you deal with a whole bunch of numbers at once in a meaningful way? Because there's all kinds of times in life when we do that, right? Like they're always analyzing how the high school students are doing on the SAT as a nation. They don't want, they want to know overall results and all that kind of stuff. And you probably know a lot of ways right off the bat. We do averages, we do pie charts, we do all kinds of things, and that's what this chapter is all about. What are ways to display or to represent, that's what an average does, a whole bunch of numbers at once in a way that's meaningful to the way our brains work. Computers can handle a zillion numbers at once, but we don't think that way. All right. So first way is to make something called a frequency table. Frequency table. So you just simply go down the list and you just say how frequently does each of these numbers occur. Here we go. I'm just going to check them off as we go. 100. So I'm just going to put like a tally mark. I got 1. 90. So I got 190. 80. 180, 60, 60, two 60s. I'm just going to keep track. How many we got? 80, 70, 70, 60. A little tedious here. 200s, 90, 10, 20. So 10, 20. 50, 50, 50, three 50s. 70, 70, 70, three more 70s. 1, 2, 3. You know the tally thing, you do the 5 when you... And then 90, 90, 90, 90, 70 again, and 90 one more time, which is 5. So there we go. So we had 0 zeros, 110, 120, 0 30s, 0 40s. I'm just going across. What's that? 3 of those, 3 60s, 6 in the 70s, 2 in the 80s, 5 in the 90s, 3 in the hundreds. So that's called a frequency table. It just tells you how frequently the various scores happen. We're going to give just like 10 different ways of talking about a whole bunch of numbers at once. Here's just the first one. So if somebody gave us this information, they said, okay, you want to know how the class did as a whole, and they put up this frequency chart, that would be better, wouldn't it, than just reading all the numbers. That would be a little more helpful. You'd go, oh yeah, it looks like most people got in the 70s, and a lot of people got in the 90s. So something like between the 70s and the 90s is where most people got. A few got below, a couple weren't really trying, and some people really aced it. You'd kind of have a feel about that, all those numbers at once, wouldn't you? That's one way. There's a lot of ways. That's just the first one. Called a frequency table, how frequently the different scores occur. All right, I'll keep going unless you want to stop me. All right, so take a look. So here's another one, Kim 103 test scores. And you can see what I did in that first part, right? I just said how many between the 80s and the hundreds. There were 8. 8 of them. I just counted them, right? I just went 100, that's 1. How many? So now they're breaking them into wider zones. They're saying, all right, the A's started 80, I guess. You know the lowest A I ever got? Do you have teachers that give 80 as an A? You have any class? No, nobody goes that low? I went lower than that. I was taking this really hard class at Cal Poly, this high-level math class, and the teacher gave us a test, and it was only 5 questions. That sounds easy, huh? They're super long. Like each one requires like a page of writing. It's math, but it's writing. It's proofs. Anyway, it's a long, complex thing. He had 5 questions. We had 1 hour. I just worked from the minute I got the thing. I got like 2.5 done. That's it. In the hour, and I knew what I was doing. I was working, and time's up, and I'm like, shoot, I only finished like half this test. I turned it in, next meeting, we get them back. I got my exam back like 42%. I mean, of course, I only did half the test, And I'm thinking, shoot. And I checked with my friend Mike next to me, and he usually got really good grades. And like, Mike, how'd you do? And he's like, I got like 45. He got a terrible score too. I'm like, man, what was this? It was Dr. Hood. I had him for several classes at Cal Poly. He was hilarious, this older gentleman, and he just always acted like we were so stupid. And he was just very, very smart, and he was always disappointed with us. So he passed him out, and it just said 42. It didn't say anything else. And he went, you guys. He said, I tried to give you an easy exam because you're coming up on your orals. We were coming up on this special exam we had to take we're in the grad program anyway. And he's like, I tried to give you an easy exam, and you guys did terrible. And he walked up, he's on bend over, he walked up to the board. He went, the A's start at 40. I'm like, yeah. My friend Mike and I were giving each other high fives. I got an A at 42% on that exam. So that was the lowest my A ever went. That was a good day. So, all right. So the A's started 80 here in this chemistry class. So how many got A's? So 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so sure enough, that's how they're getting the 8. And you good with the rest? So let me show you this part in the bottom. How about how they turn that into a like a chart thing? Let me bring it over here. How many A's, B's, C's? So because I'm going to roll it up, and then we won't be able to see it. 8, 7, 4. Oh, of course, it's going to go off the screen. What am I thinking? I don't know. I'm confused. 8, 7. All right, so we had A, B, C, D, F, 8, 7, 4, 1, 4. All right, so then it says, now make a bar graph out of that data. Okay, now which one's the right bar graph? Can you tell? Like, which one has the A's going up to 8?
B.
Yeah, it looks like B. See how the A's, the A bar goes up to 8, and that's the only one. So this is the right bar. Yeah, so A goes up to 8, B is a little lower, 7, C is at 4, see, and D is only 1, F goes up to 4. So that's pretty easy, right? Tests will be multiple choice just like this. So just finding the right bar chart. So that bar chart's a good way, isn't it, to display a lot of information. Once the class says, how'd we do as a whole in the exam? We just throw this up there. Pretty quick. We're visual, right? Picture worth 1,000 words kind of thing. It's true, huh? We, our minds can grab pictures better than we can grab like a list of numbers. That's why bar charts are nice. You see that, you go, oh yeah, that tells us people did well, a lot of A's and B's, and then not so many C's, D's, and F's. So you'd know right away. Just that picture communicates a lot, doesn't it? So bar chart, that's a good way to display a lot of information all at once. All right, so there's the grades up there. 2 A's, 9 B's, 10 C's, 3 D's, 2 F's. Which one of those charts represent correctly? Which one of those pie charts or pie graphs represent the data correctly? How do you figure that out? Remember, see, they're all in percentages and stuff. We're going to have to figure out like what the percentage should be, and then we'll know the right answer. So you guys tell me, how would you figure out like what the A's are? What percentage of all the people got an A? How do we figure that out?
I'm just taking a guess. Why don't you do like count them all up and then divide them over the number?
Yeah.
So like 8.
Totally. So yes, let's figure the total. Very good. What total? Let's add all these up, right? How many students total? What is that? 15, 26, 20. Is it 26? Is that right? 19, 21. Yeah, 26. 26 total students in the class got A, B, C, D, or F. All right, so what percentage got A? You got to just put 2 over 26, huh? Because 2 people got A's out of 26 people in the class. And then just hit the buttons on your calculator, right? Just go 2 divided by 26. Oh, I got my calculator here. 2 divided by 26. I'm getting 0.0769. And how do you change that decimal to a percentage? Just 2 places, right? So 7.69%. So which one of those charts has A at 7.69%? Oh, I didn't see B. Yeah, a lot of them do. I just saw C and D. Yeah, you're right. B, C, and D all have A at 7.69%. We're going to have to go on and do more. What's the percent for B? Well, 9 people out of 26 got B's. Let's see what that is. I'm getting 0.346. 0.3462 or whatever. Move it 2 places. 34.62%. Oh, that's just D. We got it now, huh? D. You don't even need to check the rest. You can tell the answer. Is that good on that? The percentages. Part over total. So pie charts are good. If the class said, hey, how did we do as a whole? Throw up a pie chart. You know, what's the big green one? That's C. Most people got C's, followed by a lot of B's, just a few A's, not many F's, a few D's. You would know. Pretty quick. Good visual for how the group as a whole did. So this chapter is all about communicating a whole bunch of numbers at once. All right. Let's keep moving if you're okay with that. Okay, the bar graph describes the scores of a group of students on a 10-point math quiz. So that's how they did. It says how many students took the math quiz. How did I come up with the answer of 40? How many students took? So you're supposed to somehow be able to take this bar graph and figure out that that means 40 people took the quiz. How do you know that? Kind of running things backwards now. Instead of making a bar chart, we're reading a bar chart. Huh? They're starting with a bar chart. So how do we read that thing? How do you look at that and know 40 people took it? How's that data for 40 students? Yeah, the height. Because see at the left here, frequency means number of students. Frequency always means how many, huh? How many students? So how many students got a 3? This is the scores down here. So how many students got the worst score that people got? 3. Looks like 4 students got a 3, right? 4 people. And then 4 people got a 4. How many people got a 5? 2 people. 2 people got a 5. How many got a 6? 4 people. You guys see how I'm coming up with that? I'm just finding the height of the bar. The height of the bar is the number of people, isn't it? It's the number of students. I'm just going to add these up when we're done, right? How many students got a 7?
13.
Looks like 13, doesn't it? Yeah, it's hitting right here, huh? And then how many students got an 8 and a 9? It's the same, whatever it is.
5.
Looks like 5, huh? Yeah, looks like it to me too. 5, 5. And how many got a 10? Perfect score? Yeah, it looks like 3, doesn't it? So just add those up. If you just add those up, I guess you get 40. 40 total students in the class. Does that make sense? The heights of the bars is how many students. What percentage of the students scored 2 points? Now, nobody got. The lowest score was 3. So it's weird that they want you to put 0.0. Take note of that. You don't want to. That would be frustrating to me in the homework. I would type in 0, hit enter, and it would go no. And be like, what? What do you mean no? I want 0.0. That's dumb. That's really dumb. But for whatever reason, that's what they want. I think they want 0.0. That's technology being kind of dumb. All right, number C, or letter C. If a grade of 6 or more was needed to pass, what percentage of students pass? 6 or more is passing. So, what percentage? You see my answer there. See if you can figure out how I got that 75%. I'll give you a second. What percentage got 6 or more? Give you just a second.
On the bottom?
Yeah, score, right? Got a score of 6 or more. Give that a try, see if you can see that. So how many got a score of 6? 4. See, all these people got scores of 6 or more, huh? The ones I just circled, all those people got scores of 6 or better. So you just add those up. So 6 or better. How many was that? That's 4 plus 13. 4 plus 13 plus 5 plus 5 plus 3 over the total. Total's 40. We already know the total is 40, huh? 40 people total took the quiz. So what is that? 17, 27, 30 out of 40. Divide in your calculator, 0.75, move the decimal 2 places, 75%. And I guess they want you to put .0. They always want it. I don't know why. A decimal. Did it? Just take 75? Great. 75%. Good enough on that? I'll keep moving if you're good. Okay, use the pie chart to complete parts A through C below. Possible cause of death in a population among 18 to 22-year-olds. 18 to 22-year-olds. Okay, so there's different causes of death. Now they're asking the question, is it quantitative or qualitative? You ever heard those words before? What does it mean when somebody says that's quantitative? What's that? Has to do with numbers. Yeah, a quantity is a number. Yeah, it's a number, right? And qualitative basically is not a number. So, like, if somebody said, how'd you do on that exam? You said, pretty good. That'd be a qualitative answer. You didn't give a number. Or somebody said, how'd you do on that exam? You say, yeah, I got 83%. And that's a quantitative answer, right? So, yeah. So, now there's different kinds of questions that can go different ways. Like if somebody said, they're asking, is cause of death quantitative or qualitative? Somebody said, hey, my friend died. How'd your friend die? 7. No, it's not a number kind of question, right? It's a qualitative kind of question. It was cancer or it was whatever, right? So it's qualitative. It's not a number. Cause of death is not a number. Based on the data provided in the pie chart, estimate the number of 18 to 20-year-olds who, I don't know, it's off the screen, huh? So I got to, not a number. Cause of death is not a number.
Oh, so it's not like,
Yeah,
it's
like,
not there on the chart where it has numbers, is that what you're saying?
I'm just saying the answer, if somebody asked you, how does a person die? You would not answer with a number. You wouldn't say they died because of 5. Right? You wouldn't, it wouldn't be a number. It's just simply as that. I know you're looking for something deeper. It's really just that. Now, okay. So, part B. Based on the data provided in the pie chart, estimate the number of who died because of accident. Yeah. So how do you figure that out? They're saying it's 40, accident is 45.588. Accident right here. Accident is 45.588%. Those are all, it's a percentage. So 45.588% of people died by accident. So what they're asking me, how many? I got this 8,912 answer. How did I get that? How do you figure out how many? They're telling me what percentage in the chart, but how do I turn what percentage into how many actual people that was? What do I do?
Move the decimal.
Move decimal? Any ideas? What can we do? Find out how many actual people died of accidents.
Well, it gives you that number for the population or something.
Yeah, where's that?
10.
Right there, yeah. N, exactly, good job. N, that capital N is the number of total people in this study, which is, whatever it is, 19,548. So that means all this information they're giving me is based on a total group size of 19,540. So out of 19,000, I keep messing that up, out of 19,548 people, that these, 45% of them died from accident, 13% from homicide, da-da-da-da. So, okay, so how do I do it? What do you do with this percentage and that number then? So if I said, hey, 45%, if I said, hey, 30% of this class is going to get an A. 30%, and we have 20 people. Let's just turn it into, what I said, 30% of the class, 30% of the 20 people in this class are going to get an A in the end. How many people is that? What is 30% of 20? Well, how do you calculate that?
X divided
Exactly. Of means multiply. Have you heard that before in math? Of means multiply. So you would just, that's exactly right. You would just take 0.30 and of is times 20, and that would come out 6 people. Does that make sense? So yeah, whenever they say of, whenever you go blah, 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 of, blah, 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 that means times. That always means times. So 45% of the 19,000 people died from accident, huh? So that would mean 45, you got to turn it back into a decimal, totally right. Yeah, you got to turn that person. Whenever you're going to use a percentage, you got to turn it back into a decimal, right? So turn it back into a decimal, it's exactly right. 0.45588 times the 19,548, because it's of, right? It's 45% of the 19,000 people. So multiply that, and I guess that comes out 8,912, or rounds or something. It says round to the nearest whole number. So about 8,912 died from accident. That good? Questions on that? And finally, estimate the size of the central angle of the slice representing the category other. Other. So, how do we do that? Got my answer there. How'd I come up with that? I'm going to do the category other. So other's up there. Other is 21.513. What do you think? This is on the. This is most of you guys, right? You're young, 18 to 22-year-old. This is a list talking to you, maybe. I heard a list for me on the other end. I'm getting older. I've hit 50, so the AARP is going to be sending me the retirement stuff pretty soon, I think. And I heard a list. I was listening to something the other day that said retired AARP magazine. I wasn't reading it, but I heard somebody talking about it. Saying that they list accidents among retired folks. So it's the other end of the spectrum, right? This is death among young people. This was accidents, wasn't death. Accidents among old folks. And in the list was shocking to me. One of the items on the list was brushing your teeth. How do you get an injury brushing your teeth? If I ever get an injury brushing my teeth, I'm too old at that point. I think it's over. I'm not sure how that happens. But there was a lot of them. There was like 1,000 something last year in the United States. Teeth brushing injuries among retired people. I'm not sure. It's a sharp toothbrush, I guess. I don't know. All right, anyway, so it reminded me. So this is the young. And so how do we figure out an angle? How do you figure out an angle? That's what they're trying to figure out. Like, where's the other? It's this green. It's this angle right here, huh? This angle right there. The green is the other, right? So basically, how big is that angle right there, that central angle? Well, it's 21%. Let me give you a hint. It's it's 21, what is it? 21.513. It's 21.513% of the whole circle. Right? It's 21.513, it's a 3 there, 3% of, and you know of means times, of the whole circle. Now, how many degrees in a whole circle?
Away from my desk. Please leave a message and I'll get back to you as soon as possible. Thank you.
Is it just that thing, or did somebody broadcasting from the main administration office and they don't realize they're on live? All right. Anyway, so how... Maybe if I lift it, put it down. Is this you, Johnny? Are you expecting a call? I just have a call right here.
Are you still there?
No. Yeah. So, how much in a whole circle?
360.
Yeah, 360, right? All the way around is 360 degrees. So when we say 21.5% of 360 degrees, we're trying to go to degrees, right? So whole circle is 360. So then just turn it, now we're gonna use that percentage. What do you always do when you're gonna use a percentage? You gotta make it a decimal, huh? Move it back 2 places, 0.21513. What does of mean? Times 360 degrees. Multiply that, you get around it, you get the 77 answer. Does that make sense? That's how you find the angle. It's of 360. It's that percentage of the whole circle. Right? Because they said other is 21%, so it's 21% of the whole circle of 360. So good. So we can find angles in a pie chart now. We can deal with percentages. Any questions on that one? Just making you a good consumer of information. That's what the purpose of this is. Be able to read these charts and know what they're saying. Okay. So, let's give this a try. Estimate how much money, here comes the first question. It's a pie. We're basically reading a pie chart here. Estimate how much money the federal government spent on last year's defense. Well, it looks like defense is 24.6%. Defense is 24.6%. And how did I come up with $713 billion? It's 24.6% of the whole amount, right? That's what they're saying with a pie chart. They're saying the government spent 24.6% of its whole budget, of the whole amount on defense, right? So what is the whole amount? That's the 2.9 trillion, isn't it? Now the trick is they want us to answer in billions. So we got to change from trillions to billions. Has it ever occurred to you that whenever you go from grouping to grouping, like thousands to millions to billions to trillions, that's 1,000 of the lower category, right? Let me show you. What happens if you take a number like 7 and you multiply it by 1,000? What does it do to the 7? It adds 3 zeros to the back, doesn't it? So whenever you take any number and you multiply it by 1,000, it just adds 3 zeros to the back. Isn't that what it always does? So what that means then, if you're dealing with a number like, let's just take 1,000 to start with. If I times that by another 1,000, what's it going to do to it? Well, it's going to add 3 zeros to the back and become 1,000,000. And what if I times it by another 1,000? What's 1,000 millions? Well, it adds 3 zeros, right? Whenever you multiply by 1,000, it adds 3 zeros. And that's called a billion, isn't it? And then if you times by 1,000 again, 3 more zeros, that's a trillion. And you get the idea, right? So anytime you multiply by 1,000, it adds 3 zeros, it jumps to the next naming category. From million to billion to trillion. So that means 1,000 million is a billion. And 1,000 billion is a trillion. It's another way of saying that. You catching what they're saying? So 1,000 of anything jumps you to the next name category. Right? Adds 3 zeros. So, and that's how the naming categories go, by 3 zeros. So when they say 2.9 trillion, multiply that times 1,000, and that's 2,900 billion. Did that little operation make sense? 2.9 trillion is get rid of that. 2,900 billion. Those are two ways to say the same thing. You guys tracking with me?
Wait, where did it go? Okay, so the 2.9 times 1,000, what is that?
Yeah, so that's what I'm saying. Whenever you want to, I want to change names. I want to change from trillion to billion.
Okay.
Yeah, so whenever you want to change names, you got to multiply by 1,000. That jumps you from name to name. Yeah, from billion to trillion to million, just from name group to name group. Yeah, gets you multiplied by 1,000, right? Because just under 3 trillion is a lot, a billion, huh? So it makes sense. Multiply by 1,000. 2.9, multiply that by 1,000, you get 2,900 billion. 2,900 billion. Okay, so 2,900 billion. So now we have to, why do we have to do that? Why did I do all that? Because they want me to answer, they forced me to change it into billions as far as the answer there. They hardwired the billion word in there. I have to give it to them in billions. Even though they started me out with trillions, I had to change to billions. So I multiplied by 1,000. Now I've got what's that? That's the total budget. Right? That's the total amount of the government's budget, 2,900 billion, the same as 2.9 trillion. Right? Anyway, so now I can answer the question. How much is spent on defense? 24.6% of the 2,900 billion, because that's the whole thing. It's 24.6% of the whole amount. So change that to a decimal, 0.246 of times 2,900. Use your calculator. Well, I guess that's the answer. I don't know. It's the answer right there, 713. Is that good? On that, we okay? See what I did there? So I had to change into billions by multiplying by 1,000, and then I just said that percentage of the whole amount, the defense category times the whole amount in billions. All right, question B. Stop me if you want to talk about it. Calculate the size of the central angle for each slice of the pie chart. So now they want the angles. How do I take this pie chart and start giving them all the angles? What do I do? Yeah, just times 3. Everybody good? Totally. Yeah, good. I'm glad that's making sense for y'all. Yeah, you just take, okay, defense, for example, is 24.6. Just move it, make it, move the decimal back. Times 360. Yeah, it's just all these times 360, huh? So whatever that is. Times 360. I'm getting 88.56. How far do they want me to round? Round to the nearest degree. So 88.5, so round to 89 degrees. The next one's Social Security. What's that? I can't read it there. It's looks like 20.9. So 20.9, move the decimal back 2 places, 0.209 times 360. And I'm getting 75.24, so 75 degrees, and on you go, etc., etc. Is that okay? Let's take each of those percentages, times 360. Because it's that portion of 360. Of means times, right? Of the whole circle. It's that percentage of the whole pie chart. That percentage of the whole circle of 360. And you can get all those angles? Y'all good with pie charts now?
And the 360 comes from the whole.
Yeah, a whole circle is 360. Yeah, hey, why is a whole circle 360? Why is all the way around a circle 360? Like, why didn't they make it a nice even, like, 100? Or 1,000? And they did make it. That's the right word. They just made it up. They just made it up. All the way around a circle is 360. What a weird number. Why didn't they pick, like, a nice even 100? There is a reason. I wonder if you can come up with it. Or 1,000 or something clean. And then a right angle would be 1/4 of that. Would only, if you did 1,000, right angle would be 250, right? 1/4 of that. Instead of 90, right? Why did they make all the way around? And they did. They just made it up a long time ago. That all the way around a circle, hey, we're going to call all the way around a circle 360. And then all the other angles come from that. That's why 90 is a right angle. It's 1/4 of 360. Or if you turn halfway around, you do a 180, they say, right? It's half of 360. It all comes from 360. So why did they start with 360s all the way around? Why didn't they use a cleaner number? What do we know goes all the way around?
It's not like the year.
Clock.
Yeah. Yeah, it's the 365. It was close. It was back when they first used angles when they were navigating the sea by the stars, and they were using angles that way. And back then, their closest estimate of how long it took us to go around the sun was about 360. They didn't know the 365 and the leap year and all the more specifics we now know. So 360 was the estimate for us to go around the sun. So they said, okay, that'll be the full way around a circle, 360. That's where they came up. So it's just made up. I just want you to know, it's just made up. They just made it up, and all the rest come from that. You know, this is probably the last math class for a lot of you, right? So I do want to give you a little bit of, do you know what math does? You know, I don't know, because some people it's kind of a big fog. Math is made up. You know, I've said that several times. I want that to be clear as you come out of college. You know, math is made up, but it's made up to describe things that are in the real world and help us do things in the real world. Just good to know, coming out of college, you know, how math fits in real life. You know, it's made up, but made up to describe things that are real. So they just made up that 360, and then it flows from there. All right. Anyway, let's move on. How we doing? So is that number 6? So good. So we finished that. That's number 6. Yeah. All right.